section 14 is about enlargements. Section 14.1, this first part of it on page 210 to 11, is an introduction to enlargements. You've done it before, Key Stage 3, probably back in year 7 or maybe 8. It says in these diagrams A has been enlarged to give B, so that's the baby one, that's the mummy one, that's the baby, mummy, baby, mummy. What is the scale factor of each enlargement? No central enlargement required, just count some squares. So A is 1 square across, B is 3 squares across, scale factor is going to be 3. Simple. If you work it a different way, you can see A is 2 squares tall. If you count B, 6 squares tall. 2 times 3 is 6. It works. This one, part B, A is 1 square along the base. B is 1, 2, 3, 4, 5 squares. Scale factor 3. Scale factor 5. Okay, very easy. Here we have to work with little a. So A is actually 1 square, 2 squares at the base. B is 1, 2, 3, 4. So I've gone from 2 to 4. That means it's a scale factor of 2 because I've doubled each of the lengths by times 2. Scale factor 2. Is that fair enough? So 2 units to 4 units. I've gone from 2 to 4. How do I do that? Multiply by 2. Dead easy. That's question 1 done, and that's your grade E sorted. Question 3. I've got to do some drawing now. I'm going to try and do it nicely. Enlarge each of these shapes by a scale factor of 2. I may not do them all. I might get really stuck. Anyway, essentially I've got this H here. It's 3 squares tall, so my enlargement should be 6 squares tall. This little base here is 1 square across. I've got to go 2 squares across. Let me see if I can start drawing skillfully using my line facility. Keep it crisp, keep it nice. Right, let's try and do H then. So it's 6 squares tall. 1, 2, 3, 4, 5, 6. Okay, so instead of going 1 square across, I'm going 2 squares across. Instead of coming 1 square down, I'm coming 2 squares down. 1 across, so 2 across. It's getting nice and fat, isn't it? Go back to the top, 2 squares, come out 2 squares, come down 6 squares, come across 2, go up 2. Remember, it's scale factor 2, so I'm quite happy with this actually. There it is. I know it's a little bit fatter, and anyway, because the squares from the book are slightly bigger than the squares on the grid that I've got on display, but essentially I've gone scale factor 2, and I'm now feel bold enough to do this one. So here I go. Again, 3 squares up, 3 squares across, times it by 2, so we 6 and 6. So here we go, 6 and 6. 1, 2, 3, 4, 5, 6, and then go 6 across. What have we got here? 1, 2, 3, 4, 5, 6. 1 square up, well that's 2 squares up. 1 square in, that's 2 squares in. 2 squares up. Oh, don't I have to do that again? That's better. 1 square up becomes 2 squares up, and then go back home. I'm really happy with that. That's the enlargement scale factor 2 for that one. Triangle's a little bit tricky. Don't try going across the diagonal like that. If I've got a base of 3, I want a base of 6. So 1, 2, 3, 4, 5, 6. If I've got a height of 2, I want a height of 4 units. 1, 2, 3, 4. Now obviously if I join the ends, I've got it right because I know my base is correct. 1, 2, 3, 4, 5, 6 and 4 up. So if I join the ends skillfully, I've got myself a times 2 enlargement. That's really, really nice. I love that. I can just look at that all day. Right, next question. Doing, what's it say? It says enlarge the shape with a scale factor of 3. Alright then, so I need to work out, let's start down the bottom here somewhere. So if I make this my point C, just there, and now to get point B I need to go 3 across and 1 up, but to do it by a scale factor of 3 I need to go 9 across and 3 up. So let's see if I can do it then. 1, 2, 3, 4, 5, 6, 7, 8, 9 across and 3 up. 1, 2, 3. So that's my new B position. And my A position, if I start from C, I'm going 1, 2 across, 1, 2, 3 up. So if I'm going to times it all by 3, I'm going to go 6 across and 9 up. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6, 7, 8, 9. Oh no, I've gone into the stupid question. Great planning, great planning. Start nice and low. There's my C. Do it right. Right, 3 across, 1 up. Times it by 3. 9 across. I'm going straight into my grid now. I'm angry. 9 across. 1, 2, 3, 4, 5, 6, 7, 8, 9. And 3 up. 1, 2, 3. I love the way it drags it. It's really nice. Now I'm going to go from B to A actually. I've gone 1 to the left and 2 up. Multiplied by 3. So I want to go 3 to the left and 6 up. So grab my pen here. 1, 2, 3 to the left and 6 up. 1, 2, 3, 4, 5, 6. I love the way this software does it. There you go. I didn't even need to put a little cross down there. So I'm going to label that because I'm happy with it. So I want to call this, that's going to be C dash because it's the image of the original C. That's going to be B dashed and that's going to be A dashed. And I've enlarged it by a scale factor of 3. Part B. A similar triangle to ABC was enlarged by the same scale factor. That means times 3. To give an image of the triangle ABC. So let me just draw the story briefly. This doesn't have to be to scale. So I've got an ABC triangle. I'll call it CBA. And I'm going to enlarge it and make it look sort of okay. So C dash, A dash, B dash. Again, it's all rough. Now, it says that A to B, A dash B dash, and onto this one here, is 6.708. So let me label it. 6.708. It's always good to draw a picture so you can see what you're doing. And it's asking me what is the length of AB, in other words this little side here, compared to the enlarged side there. Well, this is times 3 of the original, which is times 1. So imagine if this has been enlarged 3 times going in this direction and the long side is 6.708, I simply have to divide by 3 to get down to the original size. So 6.708 divide me by 3, grab my calculator because I am allowed. So 6.708 divide 3 gives me 2.236. 2.236. And I've got to give my length to 3 decimal places, and there it is. 2.236, and that was in meters, so this 2 will be in meters. And that's it. Question 4 done. Have I done a question 5? I don't know. Let's have a look. I have. Let's do question 5. This will be the last part for 14.1. Right, triangle A is enlarged with a scale factor 3 to give triangle B. So I'm going to draw that as a rough sketch. So triangle A is enlarged 3 times, so let's make it look like really big, to give triangle B. Again, it's all rough. Now, one side of triangle B is 7.5. Let's pretend it's this one. And then it says, what is the length of the corresponding side of triangle A? In other words, this mystery side. So that corresponds to that, that corresponds to that, and this one corresponds to that, okay? Let's just write about the excess mess there. I don't like a mess. Alright, that's that. So hold it. If I've gone from A to B and I've multiplied by 3, this is a scale factor 3, then to go from 7.5 back to the baby size, I have to divide by 3. That's all I've got to do. So here I go. 7.5 divide by 3 will give me, I think it's 2.5. Let me just do it anyway. 7.5 divide by 3. Yep, 2.5. So the original x is 2.5 centimeters. That is now 2.5 cms. Alright? Now, one angle in triangle B is 45. Let's just change flavour. So I'm going to pretend that's 45 degrees. Alright? What is the size of the corresponding angle in triangle A? In other words, this one. 45 degrees. I'll tell you why. You should know that when you enlarge a shape, the angles do not change. What you've done is changed the corresponding length by a given ratio or by a given scale factor. You've either increased it or decreased it if you've got a fractional enlargement. Certainly the angles remain the same. Okay, so the answer is 45 degrees.